Welcome back everyone. My name is Sagar and we are back here with another video. So today is day 196 of our POTD series, and I know today this video is very late, and that is because like previous day, like yesterday, I just don't want you to explain the editorial solution. I was just finding a better way to explain the solution of this question, and I just found a way that is like a brute force approach and is very easy to understand. So today this question name is maximum number of toys, and it is a hard level question. So first of all, we are given n number of toys in a shop. So we are given four inputs, that is n. So this is the number of toys, and in our array, we are given the cost of each toy, and after that we will have two more inputs, that is the, so we have q number of queries, and this is our query number of queries, and we are given an array list for our all queries. That is our array list of array. So like we write integer array. So data type is integer, and this is a collection of integer, and here we have collection of array list. Okay, so if you are even a beginner, you will just understand this solution very easily. So for our any query, we are given c amount of money which you can use to purchase the toy. So we have total c amount of money, and also there are k broken toys, and you won't purchase them. So first of all, there are two inputs c and k. So they are definitely there will be two inputs in our query, and k is the number of toys, and k can be also zero. So k number of broken toys are there. And the task is to calculate the maximum number of toys that we can purchase using C amount of money. So see the thing. We have some specific amount of money and we have to purchase the maximum number of toys. So what you will do? You will just select only the toys which have minimum amount of cost. So suppose you have X amount of money, and let me just write here. Suppose you have this much amount of money and you have some number of toys, that this toy will cost this amount of money, and this toy will cost this, and this will cost this. So what you will do? You will always select the toys that have minimum cost, right? So you can select this and you can select this, and by adding them, you can just see your cost is nearly equal, and you just cannot buy this toy, because after adding this toy you will just exceed your money. Okay, so you will just get the maximum number of toys. So yeah, that is the basic thing. That is our brute force thing. Okay, and after that, in our queries, what things will be given? So first of all, one base indexing is used. Okay, and you have to remember that thing, that is for our input values, and each query is treated independently. Query definition. Okay, in our queries, what things will be given? The first element represent an integer c, where c is the cost, total cost that we have, total money that we have. And the second element represent the number of k, that is the total number of broken coins. And the next k elements will represent the indexes of broken toys. So that means we cannot just sort the array according to our price of toys, because now we know there are some broken toys also. So suppose we have, this is price of our first toy, that is the price is 2, that is the second price of our second toy, then third, then fourth. And if we want to just buy some toys that have the smallest value, then what is the brute force approach? So first you will think that we will just sort this array according to their price. So 1 2 3 4, but we cannot just do that, because we know there are some broken toys. Suppose this is broken and this is broken, and we are just given the indexes. So in our queries we will given indexes that third toy is broken and fourth toy is broken. So suppose for our given example, I will just write here this example. So we are given 8 and 6925, 6 9 2 and 5, and we are given the in our first query we are given 12 amount of money and two number of broken toys. So total money we have is 12, so we can buy toys worth of 12, we can say 12 cents. And we have third and fourth toy as broken. So that means third toy is this, because this is one base indexing, this toy is broken and this toy is also broken. So we have to remember that. So what we will do, we have to also store indexes according to the elements value. And so after that, what we will do, first of all, the brute force approach is saying that we have to buy maximum number of toys with this money. So we will just sort the array according to their amount, according to their cost. So what we will do, 2 5 6 8 8 9, but that is not what we will do, because after that we will just select this one and this one, and 2 plus 5 is 7, and after that we cannot select this because it will just exceed 12, right? And that means we are buying these two toys, but that is not the thing. We cannot buy these two because we know this number of toy, this is broken, so we also have to store the index of this. So what we will do, we will also store the index with these value. So we will just create a pair class that we just use data. We will just create a data class that will store this integer value also with the index. So we will just create a class here, and I will just show you. First, I will just do the sorting. So what we will do, this is our fourth index, right? So we will just store two. We will always sort according to their cost value. So two, and the index is 1, 2, 3, 4. So index is 4. And you can also store according to their one base indexing and or zero base indexing, but we will store here according to one base indexing. And after that, this will be 5, and the index is also 5. And after that, we will have 6, the index is 2. This is according to their one base indexing. Okay, and after that, we will have 8, that is the index 1. And after that, we will have 9, the index is 3. So after this, what we will do, first of all, we will just get this value, and we will see, is this the broken toy? So we will create a set that how many toys are broken. So 3 and 4. So we will just create a set that will contain the index of broken toys. So we will just first get the index. So this index is 4. And is this the broken toy? Yes, it is the broken toy. So we will just not select this. And after that, we will just check on second toy. So value is 5, and this is not broken. So we will just buy this toy. And now the money we have is 12 minus 5 is 7. So now the current money is 7, and we just buy the toy that have the minimum cost. And after that, we will just buy this toy also because our money is greater. So this toy is also not broken, and we also bought this toy. And now you can see the answer is 2. So that is our brute force approach, but that is not going to get accepted because let me just estimate the time complexity. So n log n is this. And after that, we have to traverse in our queries, and for each query, what we have to do, first of all, we have to traverse in this whole array. So n for this, and I think there are k number of we can say broken toys. So we also have to traverse in that to make our this set. So for k, so n log n plus qn plus qk. So I think that is our overall time complexity. Yeah, that is the estimate, but this is not going to get accepted. But our final solution is something like this. So we will also implement this. So first of all, what we will do, we need this pair class, है ना? And first we will create the pair class, and we will sort this thing, and after that we will continue. So first of all, I will create a data class that will be pair, and that class will be of integer to integer. So we don't have to make it generic. I will just make it like this. So it will have, I will also create a getter and setter method. Okay, so private integer key, and it will have some value, key and value. So the key and value will be, key will be equal to our value, that is the cost of our toy, and the value will be equal to data. So you can also write here a and b. So that is totally your choice. I will also write here cost and index. Okay, that is what we can write. So after that, we can just create a constructor here. So that is the simple thing that you can use. Okay, I can write here integer a and b. I think this will typecast automatically. I hope so. And b. And after that, we can just create a getter for this. Both values, public integer, or we can also write here int. That is not a problem. We can also write here int. I don't know why I was writing here integer, but this is our int. And after that, this will be get key. Okay, get cost. We can write this dot cost, and I will just do the same thing for our index. I think yeah, this thing is okay. If it is not going to get accepted, then we will create it integer wrapper class. Okay, so we just created our data class that is something like this, and this is more like a boilerplate code. And let me now just create this thing. I will just sort the array and create it in a pair. Okay, so we have to create an array list of pair. Array list of pair. I will just call it ARR, and we can also define here size so that we will not create our dynamic array, and it will be of size n. And you know the problem with dynamic array. If you don't know, then you can just go and watch out our arrays video. There I completely explained the concept of dynamic array and how array lists work. So after that, what we will do, so we will traverse I should be less than n, and at every step what we have to do, array dot add new pair. That is the same thing what we were doing. This is the first value, that is the cost, and that is the index. Okay, so this is the thing, we are creating a pair of cost and index. So suppose this is 2, so this is cost, and the index is 1 2 3 4 4, and I think we have to write here +1, or we can just write here zero base indexing. That is not a problem. We will just make it zero base. Okay, so we will just go with zero base indexing, and after that now we have to sort. So what we will do, collections dot sort and arr, and I will just pass a lambda function here. So for any two values, what we will do, we have to sort according to their cost. So I will just get here a dot get cost minus b dot get cost. So now this will sort the given arr according to their cost value. So this is their first value. Okay, and after sorting, so we will just have something like this. So I will just create it, and let me show you. So first of all, we will have 2 4, and after that we will have 5 5 6 2 and 8 1 and 9 3. So we'll have all these values. Okay, so this is our collection, and I hope this is a good handwriting. 5 5, I hope you can understand this. So after that, after we sorted our array, so what we have to do now, we have to traverse in our queries. So from 0 to I should be less than q, and now what we have to do, we will just get the cost, and that will be cost will be equal to cost can be maximally 10 to the power 9. So what we will use here, we will use here long data type. C equal to queries dot get at I, and that is at 0th index. And after that we will just get how many number. Okay, we have to now also create a set. So that thing we were doing here, so we have to create a set, and every time we have to check. So we will just create a set here of integer that will tell us the damaged products, damaged toys. And after that we have to get k number of toys, and that will start from our second index. Okay, so we have to, because on 0th index we have this c. So you can see here, on our 0th index we have the cost, on our second index, on our one base index we have k, that is the number of broken toys. And after that, from our index 2 up to j should be less than queries dot get at ith query dot that is the query, and dot size, I think, yeah, that is it, and j plus plus. So we will start from index 2, and even if there is no damaged product, so we will just get the size as 2, and 2 should be less than 2, so we will not enter in this block. So I hope now you understand this loop what I am writing here. And after that we just have to add all the damaged products. Damage dot add queries dot ith query dot get at j, so jth damage product. And after that, what we have to do, we have to just select all the products one by one. So we will just traverse in our this array list. So we will just start traversing from 0 index, they should be less than n. And also we have to specify another condition, that even if we have enough cost to buy these toys or not. So we have to also check for our how much money we have. So this is c represent our total money that we have currently. So c should be greater than or equal to our current value. So arr dot get at jth value dot get cost of this toy. So if we have enough money to buy this toy, So that means we have money greater than equal to the amount of this toy. Then we will just move into this block. And what we will do, c minus equal to this whole thing. That means we are buying this toy, and answer plus plus. That is our current answer. So we can just write it as answer, or we can say current plus plus, and I will just write here int current 0, and I also have to create an answer array list of integer. That will be our result, new array list. So that is the very basic thing that we are doing until here. So every time after this loop, after we have bought some specific amount of toys, and we also have to check one condition, that this toy should not be a damaged product. So we have to also write this thing only in our loop, only in a condition, and the condition will be if, okay, yeah, we have to write here the condition if our ARR, if not damaged dot contains this index. So what is the index? This toys index, get index. Okay, so I hope now you understand this thing, why what I am writing here. So if damage set is not containing this value, so this value is the index of jth toy, and if that toy is not damaged, then we will just do this thing. Okay, and you can either write this condition or you can also skip this, that doesn't matter, our code will still give us clearly. So I'm writing here so that you can have a basic understanding of our brute force approach and how we are optimizing it. So I will just show you how we are optimizing this approach. So after that, we will just add result dot add this current, or we can say it, yeah, that is it. So after that, I will return result. So I hope now this thing is very simple, and this is very brute force approach. So we are just doing the thing that I just explained here. Okay, what is the problem here? We have to write here ith query, because this is array of queries. Okay, and is there any other issue? I hope not. Let us compile and check. Okay, there is some problem here. Let me just confirm what is it. Second answer is correct, but the first answer is giving us 3, and I think the issue is here, something here, somewhere here. So first of all, let me just check what we are doing here. So we are getting a cost, we are creating a damaged array, and damage set, that means the damage products, index of damage product. And all right, and after that we are checking for all the toys in our ARR, right? We have to check in our ARR array, and from 0 to n, so that is sorted. So that's why we are starting from 0, so that we can have a minimum cost. And I think we should remove this, and if not a damaged product, then we will just add it here. Okay, that means we also have to reduce our cost, because we are purchasing some array, we are purchasing some toy. That means we have to also reduce our cost. I think that is what we were doing. Okay, that is the issue now. I from 0 to I should be greater, j should be greater than this, jth toy cost, and yeah, let me just try to remove this thing. So let me just cross check this, what we were doing wrong. So we are creating an array of size n, and after that we are creating a pair, Okay, that is it. And after that, we are sorting according to their cost. So that's fine. And creating a result array and traversing in our queries. We are getting cost and from index 2, because on one index we have number of damaged product. From index 2 to the last index, we have all the damaged products. So from 2 to last index, we have all the damaged products. All right. So this damage thing is okay. And from our current value, if not damaged product, okay, we also have to check this condition. If we will just write this condition here, if ARR dot get at j dot get cost, if the cost is greater than our C, then we will break. I think that is fine here. Okay, I think there is some issue here. I don't know. Let me just check it. Okay, so I just found the problem, and that was this. We are storing here 0 base indexing, and we are given here 1 base indexing. So you can see here this is third and fourth element, that is 9 and 2 are defected, and that is what we are doing. So that was the problem I was also talking about. So we have to consider here 0 base indexing. So that is why we will do here -1, because we are given 1 base, and with using -1 we will get 0 base indexing. And I hope now this will work. So here we were just storing according to their 0 base index, and we are checking if the 0 base index is present in our damage set or not. And now the answer is correct. And let me just see how many test cases it will pass. So the time complexity is, you can just see here, it is taking n log n time, because our ARR is of size n. So n log n is here. Okay, we are just passing 130 test cases, and now we will just improve our code, and I will just show you how we can. So the time complexity is here n log n, plus after that this is here q, and we are creating a set of size k. So it is here k, and this is here n. So overall time complexity of this algorithm is, so this is n log n plus q into, so inside our q loop, we have k and n. So inside our q we have k plus n. So that is our overall time complexity. And now how can we improve it? So first of all, see the thing. So we have some cost. So we also have our number of we can say toys. So this is our first toy cost. Suppose I am creating a bar graph like this. So this is our cost of second toy. This is third toy, and this is our fourth toy. And we have some cost like this. So this is the total amount of cost we have, total money we have, है And what we were doing, we are selecting this one and this one and this one, and we are just adding every time that either they sum up to our cost or not. But instead, what we can do, we can just simply create our prefix sum array, that up to this toy, how many amount of money we are spending. Up to this toy we are spending this much amount of money, and up to this toy, how much money we are spending. We are spending this plus this much amount of money. And up to this toy, how much amount of money we are spending. We are spending this much amount of money. And up to this we will just add say this. And after that, what we can do, we have to just find the exact amount of money that we can spend, the exact enough amount of money that we can spend to buy maximum number of toys. That means we have to find the lower bound. So we have to just find the number that have the money which is less than our given money, so that have the cost according to our less than our given money, so that we can buy this much amount of toys. And that will be also the maximum. So we have to maintain our prefix sum array. And we will just find the index. So we will just find this thing, that this is the index up to which, so this is the enough amount of money that we can spend to buy a number of toys. So we will just get this index, and that means we are buying all the elements, all the toys, this one and also this one. But now there is a problem. So first of all, I hope now you understand this prefix something, and I will just create that thing. So now we have to also create our prefix sum. So I will create long, because we have to just add all the values, and that will obviously be a long value. Prefix sum will be, total size will be n, plus 1, because we have to say that, because first of all this value will be 0, and up to this one we will get previous value plus this current value. Okay, so that is you can just use anything to write your previous prefix sum. So that is a very basic thing. You will just you might have done this thing while you were using loops or arrays. So index from 0 to less than equal to n and I plus plus, and prefix we have to start from 1, because already on 0th index, already on our prefix 0 index we will have 0 value. So on our 1 index we will have prefix of previous value plus our array's current value. Array dot get at current value, that is I minus 1. I minus 1 because we are considering here one base, and after that we have to get cost. So current cost plus all the toys that we bought previously. So I hope now you already know the concept of this prefix tree, this prefix array, and I am not diving deep into this. So suppose I will just write here some example here: 1, 2, 3, 4, and I have total money 10. So this what will be our, this is the total amount of, this is the total cost of our toys. So one toy cost for 1 rupees, and second toy cost for 2 rupees, and third for 3 rupees. And what will be the prefix sum? So 1 here, and 2 plus 1 3 here, and 6, and 4 plus 6 is 10. So that means I can just purchase all the 10 toys, because that is our lower bound. So up to this, that means I can just purchase all the toys up to this range, and 3. So I can also buy, I have more money than 3 rupees. So I can just purchase all the toys that are, that have, that have cost greater than 3. That's sum up to 3. Okay. And after that, I can also buy 6, and I can also buy 10. And suppose further example, I also have a toy that costs for 5 rupees. So it will be 15 here. So still the lower bound is 10, and that means I can purchase all the toys that up to this index. So that means I can purchase these toys. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So I have 10 rupees, and I bought the maximum number of toys. So that is the concept of using here prefix sum. So I have to just find the lower bound. And in C++, I think there is a method to directly find the lower bound, but I will just use here binary search. So you can just see this is our sorted array, and this is also our sorted array, because we are just adding every time some value, and this will be in increasing order. So we just have to use here this in our prefix array, we will just do binary search, and we will get the lower bound. So that is how we will optimize this, instead of doing linear search and checking this thing either we have enough cost or not. So this is the thing we were checking, either we have enough cost or not. So instead of this, we will just do here binary search. So after that, what we can do, and let me just do this thing, binary search. So we have to remove all this thing. So we have to now binary search in this. So starting index is 0, and the maximum index is n. So int low is equal to 0, right is equal to n, and we will just have the answer. The answer will be of the lower bound value that we have to find. So this is the maximum number of toys that we can purchase according to our input money. So C is our input money, all right. And after that, while, so this can be a large value, so we will just use this thing, right minus low by 2, right minus left by 2. So you can also write here L plus R by 2. So that is the same thing. And if our prefix sum of this middle value is lesser than or equal to C, so that means we can purchase up to this. So if we have middle value this, so this 6 is less than 10, so that means we can purchase toys up to this, and after that we will check further. So that means we can guarantee that we can purchase toys up to this, and now we have to check if we can purchase more toys or not. So that is the simple concept of prefix sum and prefix sum and binary search. So answer will be mid. So that means we can purchase minimum this much toys, and after that we have to check more. We have to check further either we can purchase more or not. So I hope you are understanding this. And right equal to mid minus 1, mid plus 1, and after this we will have, so after this we have this value. So we will have this 10. So that means this is our index 0, 1, 2, 3. So 3 is the index up to which we can purchase all the toys, right? So 3 is the index. That means we can purchase this many number of toys. But we have a condition here. We got some problem. We have k number of broken toys, and they can be here, they can be here, and they can be also here. So we have to remove the number of toys that are broken, and that is in this range. So we also have to, now we already have the sorted value, right? So we have to check in this sorted array, and we also have to now create a map. And why map? Because we have the updated value, and we are storing here index. We have the index 3, and now we have to check either this, if we have some 2 index. So if we have 2 index, that means the 2 index is here, and we have to check the default damage product index. So if the damage product new index is 2 or not, if damage product new index is less than 3 or not. So even if you are not understanding it, let me explain you. So if we have some damage product, so 2 is our damage product, and suppose the index previous index was 2, and we have the new index as this one. So suppose the 2 is present here, and 2 is the damage product. So if we have to check if the new index of the damage product was less than our this value or not. So I hope now you understand it. If the new index of our damage product is under this, so if it is under this, that we are selecting it, and we just have to remove it now. So now we have to check if it is in. So first of all, we will create a map that will map this old value to this new value, old index to new index. So first of all, let me just create a map here. I can just do it after sorting. So map of integer to integer, that will be from index to index. And that map will be also of size n, but we don't have to specify it. We only have to specify when we are using dynamic arrays. So that will also, okay, we also have to specify it here. So the result array will be of size q, and that is the just a thing to optimize our algorithm, optimize our solution. That is not necessary. So after that, we have to traverse in all the values. I should be less than n. So we have to check if the damage index is in the range or not. So if the index of our damage toy is in our range or not. If what is the new index of our damage product? What is the new index? So we have to find the new index according to our previous index. So that means our previous index will be our key, and our new index will be value. So previous index is our key. So that means we have to get the previous index. Ith values, previous index, get index, previous index. Okay, get index is the method, and new index will be the value. So I hope now you understand it clearly. And after that, we are creating a prefix array, this answer, and after that, this is our C, left and right. Okay, we are doing here binary search, and now what we have to do, we have to remove all the values that were previously damaged. So now we have to remove the damaged values, and so we will start from checking previous value, previous index, answer -1 index, and we'll just check for all the damage products. So what are the damage products from index 2 to, okay, it is less than, I can just write here k. So obviously we can just write here k, int k equal to ith dot get at first. So we will just get here k, and we have total number of k damage products, right? So we can just write here j should be less than k. So that is a simple thing. And we will write here j plus 2, because on 0th index we don't have our damage product. We have our damage product on starting from our second index. You can see here the next k element. So on our 0th index we have cost, on our first index we have k, and our damage products are starting from 2th index. So we have to write here j plus 2 every time. And after that, we can also, okay, let me explain it to you. Let me first explain the complete approach. So suppose I am removing this element. Let me make it clear first. Suppose 1 2 3 4 5, this is the thing. And okay, so our cost is 10, and this our prefix sum, this is our prefix sum, this is our given sorted array, okay. And 1, this is our 3, this is 6, this is 10, this will be 15, okay. So first let me explain the complete approach. This is here different thing, okay. So first of all, we will check in our we will bind a search in our prefix array, and we will get this index, that up to this index we can purchase all the toys. So we will purchase all the 4 toys, but now we have to remove the toys that are damaged. So using our map and using our k values, so we know that this product and this product is damaged, and now we have to remove the 2 products that is in this range. So what is the new index of our damaged products? So this is the 1 index, and this is our 2 index. And what is the index of our k? So it is here 3. So that means it is 2 is less than 2 is less than 3, and 1 is less than 3. So that means both the damaged products are included in our range. So I hope now you understand it. Both the 2 damaged products are included in our range. So that means I have to now remove this. So that means I will just remove this 2. So this is damaged and this is damaged. So I will just remove this 2. So that means first of all I also have to place here a remainder that will tell us how many values are remaining here, because now even if we are removing the previous value, we can add further values, because we are just removing some toys. So we will obviously have more money to buy more toys. So first of all, what we will do, we will have remainder as 0, because here the sum is 10. And when we are removing 2, so it will be here 2. So that means we can purchase more toys worth of 2 rupees. And 3 is also damaged, so we will also remove 3. So it will be here plus 3. So it will be here 5. So that means we can purchase more toys worth of 5. And suppose I have more values here, 6, 7, 8, and that will be 21, 28, and so on. So this is our prefix sum, this is our input. So that means our remainder is 5. So that means I can purchase more toys worth of 5 rupees. So what we will do, I will now just linearly traverse in our array, and I will just buy more toys worth of our remaining values. So I will just purchase this value. And what is the index of our answer? So index of our answer was, okay, index of our answer was 1, 2, 3, and index was 4. Sorry, index was we are storing here according to their we are getting index according to this zero base indexing. So we will just have 4 here, and after that when we are removing 2 values, so we will also remove our answer, we will also reduce our answer. So answer will be 2, because we just removed 2 values. So answer is 2 here. And after that, when we are purchasing 5, so answer will increase. So answer will be 3. So that means we can purchase 3 toys, and our total sum will be 10. And what toys we are purchasing? This 1, this 4, and this 5. And the sum is of all these 3 values are equal to 10. And this is the maximum number of toys that we can purchase. So what things we have to remember? This remainder value, that will tell us how many remainder values are here. And this value, that will tell us how many damaged products are here. And we also have to check, when we are checking for further values, when we are adding more toys, we also have to check that this should be not a damaged product. So we also have to create a set for our further values. So we will not traverse in our whole array, but we will not traverse in our whole this array, but we have to traverse in this damaged product, okay. So we also have to check for all damaged product, and we have to create a set for all the further values, okay. So we will create a, and I am not directly using here answer, because obviously we have to reduce here answer, because we are removing some values, है ना? And after that I can just use here an index that will start from this value. We will start from all the previous values, okay. And I hope now you understand this approach clearly. And I will create a set of integer set, okay, that will be how many damaged products do we have. So that will represent damaged. And we will not we can or we can just skip adding these values to our array, because they will be obviously removed into our this set. So this is our hash set. I know the video is very lengthy, so I will quickly solve this. I will just write here what things I am explaining here. So first of all, what we have to do, we will just get the index. Okay, this is our new index. What is the index of our damaged product? So what is the index of our damaged product? We are getting this thing. So we have to write here. So in our map, what we are doing, we are creating our map, right? And we have to get from our map the new value, the new index of our previously added value. So what value do we have? We have to get. We have to get the j plus 2th value. So we have to get the all right. We have to get the zero base indexing. Where is the ith? Why I'm writing here j plus 2? Because our damage product are starting from second index and we are storing here zero base indexing, and minus 1 because we have to get obviously one base indexing value. So this is the new index and that new index is of the damage product. Okay, so this is the new index of our damage product, and if okay, if this damage product index, damaged toy index, I'll just copy this variable, is lesser than or even equal to, because our index is starting from index I answer minus 1, so we are starting from here. So if the damage product is starting from this, so equal to our index, then our answer will obviously reduce, and we have to also store here a remainder value that will tell us how many further toys we can buy. So we also have to create here a long value. So long remainder, and first of all, remainder will not be zero, obviously, because the y remainder is initially not zero. Because suppose, for example, our first toy is of 5 rupees and we have total of 6 rupees money. So we will just buy this toy, and suppose our next toy is of 8 rupees. So we will have remainder as 1. So that is our total money minus minus the prefix sum, up to this answer. So that will be our remainder value. Total money is C, and prefix sum up to this answer. So yeah, I hope now you understand this thing. And why I'm writing here answer minus 1, because our answer will be equal to middle value, and the middle value is lesser than our answer, uh, and lesser than our cost, I think. Okay, so this will be our starting initially remainder value, and we have to now add some value to our remainder, because we just removed some damage product and our answer is reduced. So now we have to add some value to our remainder. So what value do we have to add? This index value, damage product index value, damage to index value we have to add. So we just removed 2. So you can see we removed 2, and now we have to add 2 here. So now we have to add get cost. And else, if that is not the case, so if the index of damage product is after this index, then we have to store it in our set, because after that we have to check it. So that is our damage set dot add this new index, damage to index. Okay, I hope now you understand this thing very clearly. And after this loop, we just removed some toys. Okay, so after this loop, so this is our first loop that we used here, and we removed 2 and 3, and now the remainder is here 5. So the remainder is here 5, and now we have to check from there to here. So we will have 5, 6, 7, 8, and we can just buy this toy. So we can just start here another loop, that how many number of toys that we can buy more according to our remainder value. So now we have to get here another index. Okay, we can just use here this same index, and that will be equal to, we can create here new index, and while this new index is less than our n, and we have enough money, we are remaining with enough money. So that means our remaining is, we can say, greater than or equal to, we are remaining is greater than equal to our get value of this new index. So what is the new index? S, and we have to get the cost. So after that we can just add this. If it is not the damage product, if not damage dot contains this value. So what is this value? So this index S is the index that we are checking. If this is not present in our damage, then we can just add buy this toy because we have enough money and this is also not damaged. So we will just reduce our remainder value dot get cost of this. And I hope now you understand this. And every time we also have to increase our index because that can be also a damaged product, right? So after that, we just have to add it to our answer and we are remaining with one base case. And let me tell you what is it. So our base case will be here. So if our answer is equal to 0, so answer is equal to 0, that means we cannot use here answer minus 1, and that is because we cannot purchase any toy. So if the minimum cost of any toy is 5 and our money is 4, so our index will be obviously 0 and we cannot purchase any toy. So if answer equal to 0, then we just have to add this answer. So that means our result dot add this 0 and we have to continue. We don't have to move ahead. And I think all the base cases are covered. Let me check now. I wish this will not give a TLE now because it is here log n. Okay, what problem do we have here? Okay, ignore this one and variable prefix cannot find symbol. Okay, okay, now we have this and cannot find symbol current. We have to write here answer, that is the index. So I hope this thing is complete now. And the answer is correct. Let me just submit it. And the total time complexity is now q into log n plus here k here, and after that we have here. Okay, it is also giving me TLE. Let me just check. This should not give a TLE, and I will just explain what is the problem now. Okay, I think the problem is with this one. I have to make it generic to make the solution work, and I don't know why it was not working when I was creating here integer and integer primitive data type, and I don't know the reason. If you know, let me also know in the comments. And all the whole code is same. I just have to make it generic. So this pair class will be of integer to integer. So it have two values. The first value is of type that we define. So we also have to define it here that this pair class is of integer to integer, right? Like we have to also specify in our hash map that this hash map is of integer to integer, right? So that is what we are making here generics, and the total time complexity is, so here it is n and it is here n log n. So we will also only consider n log n because it is obviously greater than n. So n and this is q, this is log n. So we just optimize our algorithm a little bit, and from n to log n, log n. So we just optimize from n to log n, and all the other things are same. Okay, so that is how our solution is accepting. So I know the video is very lengthy, but it is worth watching if you are understanding this approach and if the solution is getting accepted. So thank you for watching.